Hi, this video will cover systems of equations, which is for the class NCBM 0114. However, this is very useful for NCBM 0124 as well, or any student who wants to get a little refresher on how to solve them. So we have here a couple of statements with fill in the blank, and then we have a system of equations involves two equations. Let me touch the pencil. So two equations and two variables. So for the first chapter of chapter 6 for the class 1324, this will be covered in section 6.1. And if you're in pre-cal, this will be covered in 7.1. Now, we have here a solution of the system is an order pair. So it's just like the order pair that we have here, 3, 1. And so because we have two variables, we have to have two numbers. One of those, typically we use the variables x and y. So the first number will give you, not y, sorry, but the x value. And the other one will give you the y value. All right. So here, first question says, is this order pair 3, 1 a solution of the system? And so what we need to do is substitute it. So we're going to we take equation 1. I like to number them. Equation 2. And so we have to substitute first in equation 1. So instead of x plus y equals 4, we put a 3 for the x and then a 1 for the y, and that will give me 4. And so what we're doing here is we're just checking. And we're checking if after substituting like we did here, we will get a true statement like 4 equals 4. So if it works, we say yes, it's part of the solution. However, for it to be part of the system, it needs to be true for the two equations. So now I'm going to do the same substitution. So that the equation number 2, and that one is x minus y equals 2. So now I'm going to substitute x with a 3, and then y with a 1. And again, we are checking if this is true. And so you could see that, yeah, we'll get a true statement after we substitute it in both. So now,
what if it only gets it with one equation?
Yes, so that's a great question. If it only works for one question, then it's only true for one equation, so then it's not true for the whole system. So it has to be 2 or nothing. Yeah. So even just one true is still not a solution.
Okay.
Yeah. So in this case, we say yes. The point 3, 1, or the order pair, is a solution. Okay. Now right here, let's do like summary of the types of systems that you can have. So we could have, let's correct this word here. Let's put types of systems. And based on the type of system, we'll have like solutions. So for example, you could have a solution. Well, first of all, graphically, let's just draw like the XY axis here. So when you have something that has no solution, that could be because you have two lines that are parallel. So that would be no solution because those lines will never intersect. Now, to have infinite solutions, that means that you have one line and then you can have another line just overlapping on top of it. So then every single point that is here will be part of the solution. So that's why we say infinitely many, because every single point on the line could be a solution. And this one is no solution, okay? Now, the ones that only intersect at one point, like let's say here, they have one solution. Now here, to be honest, I don't know why they have two solutions there. We could have something like that. Let's say if you had, let's say, a parabola, and then you had the parabola intersecting with a line, then yeah, you could have two solutions. So every time the lines intersect, those represent solutions, okay? Now, based on that, you call them, they have different names. So for example, if they have solutions, they're called consistent. So whether they have one or infinitely many, that makes them consistent, okay? And if they have no solution, it's called an inconsistent system. And then based on the fact that they have one or multiple solutions, we refer to them as dependent, and then this one here is independent, because they're two independent lines. All right, so consistent means it has one or more solutions. Inconsistent, no solution. When they have one solution, they're called independent, and when they have infinitely many, they're called dependent, because they're the same line.
When they have two solutions, is it going to be independent too or dependent?
That's a good question. It would still be independent. Yes.
Okay.
All right, so we're gonna solve some of these. So there's several ways to solve them. So we're gonna cover this three first, and then the next time we meet, there's gonna be one where we introduce matrices to solve the systems. And for the 1324 class, the systems, the matrices are in chapter 6. For the 1314 class pre-cal, matrices are in chapter 8. Okay, but so let's do the first, the easiest, which are graphing, substitution, and elimination. So here for the graphing, remember, let's just number our equation. So that's 1, and then this one will be 2. So the first equation, if I have this right here, right? If I try to solve for y and I just write x equals, and then I could kind of like, I could try to add y to both sides or move the negative y across, so then it becomes positive y, right? So to graph that, it will just be the parent function for all linear functions. So it will be here at 0, 0, and then 1, 1, 2, 2, 3, 3, and so on. So I'm just going to try to graph it. This method is not that good because it you know, graphing, yeah. So let's see, and then let's try to graph the other one. So the other one, I'm going to solve for y, okay? So the first thing I'm going to do is I'm going to put this positive 5x across the equal sign. So then it will be negative 3y, is negative 5y, right? I mean x, and then plus 6. And then we got to divide by that negative 3, both sides, right? So then we get that y equals, is that beeping sound coming from me or from you?
That what?
Like, it sounds like an alarm, a fire alarm.
No, I don't think it's coming from me.
Okay, so it's from my office. I need to report that. Okay. All right, so then here, this is going to be y equals, and then here, if you divide a negative over a negative, you're going to get a positive, so 5/3 times x. And then here, positive 6 divided by negative 3 will give us negative 2. All right, so now I'm going to graph that one. Because this is a negative 2, that's the y-intercept, and it's going to happen at 0, negative 2. So it will be right there. Then the slope is telling me go up 5 units and then 3 units to the right. So it's going to be 1, 2, well, 2 at the origin, 3, 4, 5. Oh, sorry, and then 3 to the right. So it's going to be right here, that point. Then I'm going to connect them. Oh, that's really bad. I'm using a touchscreen laptop, and then I'm using like a stylus. So they're not. Okay, there we go. All right, so then right there, that point, that happens to be the intersection. And I think it looks like it is at 3,3. So if we weren't sure, we could substitute like we did on the beginning. That one will obviously give us a true statement. And then if I take this one and I use 3, 3 for x and y, it will be like 5 times 3. Oh, no. Yeah, I don't like writing on this thing. Okay, 5 times 3 and then minus 3 times 3. And then we're checking if that will give us 6. Okay, so I'm checking with the second equation. So it will be like 15 minus 9. And then we ask ourselves, is that true? Yes, it is, right? 6 equals 6. So yep, we got even though our graphing was not perfect, we still got the correct solution, 3,3. You could also use, like I would recommend, like when you're doing your homework, even if you don't have to solve it by graphing, go on Desmos. Remember that website? Let me write it here. And you could graph them both. And Desmos actually allows you to graph in this form. Like you don't even have to solve for y. So that's like a really, of course you cannot use it on the test, but that's a very good way to check your work while you're doing your homework.
Okay.
So let's see. Now we're going to use substitution, okay? So the things with substitution is first, we're going to take one equation here. So we take the first equation, and I'm going to solve for x. And the reason I want to do that is because the reason I chose x is because it has a coefficient of +1. So it's like really simple to solve for it. So then it will be x is equal to y. Now our next step is we're going to take the other equation, equation number 2, and then we're going to substitute. Instead of x, we're going to use what we found here. So instead of x, we're going to substitute it with a y. So substitute x with y. So then this x right here, that's the one that I'm going to change with a y, okay?
Okay.
So this is going to be 5 times y, and then minus 3y equals 6. From here, we have 5y minus 3y, so that will give me 2y equals 6. And then from here, y will be equal to 6 divided by 2. So then we say that y is equal to 3, which is the same thing that we found over here by graphing. Okay, so that's halfway. Now that we have one variable, we have to go back here. So that will be like our third step. We go back to the, and in fact, you could use like any of the original equations, but it's kind of easier to use this one because you already solved for x, you see? So that to find the value of x, we have this expression, x is equal to y. So if I substitute the y that I found here with a 3, that will give me the value for x. That's an easy one to work with. Like, let me see if maybe on the next one we'll have a little more complicated. Okay, now let's do this elimination one. So the thing with elimination is that you try to cancel one variable with the purpose of just getting a one equation with one variable. So let's see. So if we had something like x plus y and then x minus y, kind of like the one that we had at the beginning. Let me see it. 4 and 2. Okay. All right. So whenever you have opposite coefficients like we do here, you see how we have positive y and negative y. So we could go there and cancel those automatically. This method is also called addition. So then you cancel that, and then you try to add equation 1 to equation 2. So this will be 2x is equal to 6. And then x is equal to 6 over 2. So x is equal to 3. So that's like an easy one for elimination. However, the one that we have here, you see we don't have opposite coefficients. So we cannot just eliminate. So when that happens, you have to actually multiply one or the two equations by a number. So what would you like to eliminate, x or y?
Y.
Okay, so then since we have negative 1 here and negative 3 here, what we wished we had was a positive 3y and a negative 3y so that we can cancel, right? So the only way we can make that happen is by multiplying the first equation times a negative 3. And the reason it's a negative 3 is because once we multiply negative 3 times negative 1, we're going to get this, positive 3.
Okay.
So then we have to distribute to the whole equation. So negative 3 times x, negative 3x. And then negative 3 times negative y will be positive 3y. And then we also multiply times the number, okay? So that will be negative 3 times 0 is still 0. Then I'm going to copy the second equation that we have here. So 5x minus 3y equals 6. Now we have that opposite coefficient thing, so we can cancel them because they equal 0. Then we're going to add these two or combine them. So negative 3x plus 5x is equal to 2x. And then here we have 0 plus 6 is equal to 6. So then to solve for x, divide by 2, So then that will give us that x is equal to 3. See? Now, once you have one of the numbers, you can use any equation from the originals. So I'm going to use this first one. And it says x minus y is equal to 0. So now what I'm going to do is substitute the x here with the numerical value that we found here. So it's like 3 minus y equals 0. And we want to know what positive y is, so I'm going to take that across. Since it is subtracting on the left, once I move it across, it will be adding or positive. So positive y is equal to 3. So it was the same problem, but we solved it in 3 different ways. For all of them, we got the same 3, 3. Meaning the x is 3 and the y is also 3. And then graphically, they intersect at that point at 3, 3. So this one will be independent because they're 2 independent graphs. And it is also consistent because it does have a solution. It just has one, but it's still consistent. Okay, so I'm going to move on to the next page, okay? And right here, oh, they're the same. So what I want to do is I just want to jump straight to the elimination and substitution, okay, instead of the graphing.
Okay.
So let's write here substitution for example 2, okay? And here the easiest thing to substitute to solve for it will be the y. So you try to look for something that has a coefficient of equal to 1, okay? So I'm going to take that first equation, negative 2/3 x plus y is equal to 2. And then I need to solve for y. So it's going to be y equals, I'm going to take this negative 2/3 across. So now it will be positive 2/3 x plus 2. Okay, now this one is actually more interesting. That expression that we have we're going to take the second equation, which says 2x minus 3y equals 6. And what we're going to do is, instead of this y right here, we're going to replace it with this expression here. Okay? So it will be 2x minus 3, and then we have that, this whole thing. I'm going to put it in parentheses. 2/3 x plus 2. And then we still need the equals 6. So the reason we do this is so that we just have one variable, that being x. Okay, so it's 2x. Then we have to distribute that -3 that we have here, this -3 here. So -3 times that, it will equal to -2x. The idea is that you have -3 over 1 and you multiply by 2/3. So you multiply straight across and that will give you -6 over 3, which is -2. Okay, so that's how I get it. So I get -2x. Then it's going to be -3 times 2. So that will equal to -6. And then here we have 6. So then if we combine these two terms, we will get 0. Right? 2x minus 2x. Okay. And so with that, 0 minus 6 equals 6. So then we get this like weird statement, -6 equals 6. And we know that is false. That is not equal, right? So because of that, this one has no solution. So from the first page, we said if it has no solution, it's because they're actually parallel lines. So now I actually want to graph them. Yeah, they are parallel, I can see. Okay, so let's go ahead and graph them. Let's see. If I take this equation and I solve for y, it's going to be y equals the slope, move it across, so it will be positive 2/3 of x plus 2. That's equation number 1. And then equation number 2, this one, remember how I solved for it? No, I did not solve for it, so sorry. So it's this one here, right? So let me solve for it. And it will be, we start at 2x minus 3y equals 6. So it will be -3y is equal to -2x plus 6. So then after dividing by -3, oops. -2x divided by -3 and then plus 6 divided by -3. So we will get the following. Y equals positive 2/3 of x minus 2. So that is equation number 2. And if you notice, one of the characteristics for two lines to be parallel is that they have the same slope in a different y-intercept. And if you see, they both have the same. So if I graph equation number 1, it will be here. Y-intercept is at 2. And then the slope is 2/3. So we go up 2 and 3 to the right. So it will be like right there. If I graph equation number 2, this one here, the y-intercept is here, and then the slope is 2 up, 3 to the right. So then it will look like that. So parallel lines have no solution. Okay? All right, how will that look if you were to solve it by elimination? So you will also get some crazy statement, kind of like this one, that -6 equals 6. So that's what tells you this one has no solution. So what I'm going to try to do here is make this positive y turn into positive 3y, okay? So that I can cancel it with this -3y. So for me to do that, I need to multiply the first equation by positive 3. So if I distribute here, here, and here, I'm going to get -2x plus 3y equals 2. And then I'm just going to copy the next equation, and I will get 2x minus 3y equals 6. So from here, once the next step will be to add the two equations together, but look at what's going to happen. We're going to have here negative 2x plus 2x. They cancel, right? Because they're 0. And then we have positive 3y minus 3y. They also cancel because they're 0. So now we have 0 equals, and then 2 plus 6 is 8. And so again, we get like a false statement.
Yes.
So that is something that will tell us the system has no solution.
So it's parallel.
Parallel, exactly. And so we refer to the systems as inconsistent because they have no solution. It's kind of like having one of those friends who's not a real friend. They're very inconsistent, and they usually have no solution to our problems. Okay, remember that way. All right, so let's do this one, and let's start by elimination. I'm kind of like already like thinking, oh no, it could be no solution as well. So let's try this. So you see how you have negative y and negative y? So let's multiply one of the equations by a negative 1. So that's going to give us the following. Remember, we have to distribute, okay? So negative 1 times 5x will be negative 5x. And then negative 1 times negative y will be positive y. And then negative 1 times 3 will be negative 3. So then I'm going to copy the second equation here, 5x minus y equals 1. And so again, what's going to happen is like
You're going to cancel out.
Correct. So you get 0 equals negative 2, which is false. And so again, we have no solution. And so if we were to graph them, we can graph them quickly. It will be like 5x minus 3 is equal to y. So I just took this negative y to the right and the positive 3 to the left. Okay? And if I do that with equation number 2, it's going to be 5x. In this case, this positive 1 on the left will become negative 1. And then we have the y here. So then I'm going to graph them. The first one in red, the y-intercept is at negative 3. So that will be here. And then the slope is 5 over 1. So we go up 5 and then 1 to the right. So it's going to be right there. Oops. Okay. And then the one in blue, the y-intercept is at negative 1 because that's this number here. And so we'll go there. And then 5 units up. 1 right. So it'll be like right there. Oh my gosh, my lines are off. But algebraically, we know it has no solution. All right. So we'll stop here. Hopefully this will help you out with your at least your first 2 sections, and then let's just try to schedule a meeting online. If you're busy on Wednesday, I also have office hours on Friday, so we could also do that. All right.
Okay, thank you.
All right. So I'll send you a message through Remind. Yeah.
Okay. Yeah.
All right.
Thank you.
So, bye.
Okay.
Have a nice weekend.
You too. Bye-bye.
Bye.